More fun here. I have for us Daniel Cook of Spry Fox. This is the genius designer behind Triple Town and all the cool stuff in Realm of the Mad God. You got to tell them how cool you are. Sure. Do I have to do this?
You don't have to.
All right. You all know how. You know what? You know how cool he is.
The next hour is me talking about
All
myself.
right. Cool. All right. So, without any further ado, did I show you how to work this?
How do I? Is this on?
Yes. Yeah.
All right. Awesome.
This is on. Hit it, Brian. There you go.
Sweet.
All right.
This is my Harry Potter wand. I'm going to trace pentagrams. Anyway, I'm a game designer. This is a talk about game design. I've been doing this for a while now, and the important part of this is actually a tragic slide. We were talking about at a dinner, it's like, do you consider yourself a success or a failure? And everyone was going around, success, success, success. And I was like, failure. So 17 years, which isn't that long, really, when you think about it, hopefully. But hundreds of prototypes, and then we've got a whole bunch of games that have come out of that. But I look at that and I'm like, hundreds of prototypes and maybe like 9 IPs out of that. And so that's like 90% of my life is pretty much failing. I make something, I get this idea. Have you ever had that idea where you're so excited about an idea? You're like, this is going to be the best thing ever. Otherwise, why would you even work on it, right? And you start working on it, and then it kind of sucks. And it starts sucking more. And then you see this brief glimmer of fun, and you spend another 6 months on it. And then it ends up, and you're like, oh yeah, that kind of was a bad idea. And that's sort of where those 17 years go. So one of the things I've sort of devoted my life to is figuring out, well, game design is hard, and there's a lot of failure and a lot of wasted years in life. Is there any tools out there that can help us? And there's been talks about prototyping and iteration and small team sizes, and there's lots of stuff that you can do to keep the cost down and be more efficient and prototype well. There's this crazy area of game design where these eggheads, their heads are actually shaped like eggs. It's a problem coming out of the birth canal as a child. And they like to think about game design in these very abstract theoretical terms, and then they go and they write big books on them, and everybody goes and ignores the books, because if you actually take some of these theoretical tools and try them out, they don't work very well. They're too abstract, they're too bizarre, and they're just not very functional. But I was like, I'll invest the time and energy into this to see if there's any of these that actually help me and increase the chance of these prototypes being a success. Now, these tools are interesting. They're not really like mathematical equations where you put in the numbers, you calculate, and you get an answer. Almost all these tools are they're tools of inspection. They let you look at a game, they let you look at a prototype, and figure out what's wrong, and out of the millions of possibilities, identify a handful that might be really interesting to pursue. So they kind of help you see where the errors are. It's kind of like, imagine doing surgery on somebody who has a disease, you don't know what the disease is, and someone's blinded you. That's what game design is like normally. It's like, well, I think I'll cut here. And then there's a guy who's yelling out, no, cut over there, I have the money. And it's just not very effective. Wouldn't it be cool if you could actually not be blind and see where the problem is and then fix the problem? So these are tools of inspection for the most part. They're also instruments. In social games, there was these books of patterns that people would do. It's like, here are the patterns to success. You must make a viral loop like this and have these 3 steps, and if you don't, your game will fail. And they failed anyway. What's interesting about these tools is they tend to be things that you use with craft and practice and intuition and a certain sense of insight and genius when you perform them. They're not necessarily something that you're just going to pick up and use immediately and say, no, my games are better. Years of learning for each one of these. So let's get into them. The way this is structured is I'm going to give you the brief overview of each one of these. because each one is probably multiple talks long, I just want to say, like, here it is, be aware of it. I expect you to go off and then spend the next 5 years, if you're interested in it, digging into it and educating yourself. And if you get just one of these out of this entire talk, that's awesome. I've done my job, and I can go off, and I have a pony outside. I'll ride him home. All right, so loops. Loops are this. And this is what, check out this. Isn't that cool? Loops. So all games are made of these things called loops. And the first person I know of to talk about them was a fellow named Chris Crawford. And he talked about how games are sort of this interactive conversation between the computer and the player. And as game designers, our job is to design that conversation. And you find these things, these little structures, these abstract structures in every single game ever made. Like, it's impossible for you to come up with a game that does not have these in them. So, we start out with this concept. The player has a mental model. The player says, I think I know how the world works. I think this is a schema of how things work. I see this object, this chair thing, and I know I can probably sit in it. That's my mental model of the chair. I can sit in it, keep my bum all nice and comfy. If I sit in it too long, it starts to sweat. Mental model of a chair, right? Now, there's things that I look at in the game, and I say, okay, there's actions I can do with this game. There's affordances. It tells me that I can do something with this game. I look at my mental model. I look at the actions, and I say, I think I'm going to do this. So when you see let's say a NES for the first time, and you're playing Super Mario Brothers, you might say, oh, it's a controller, and it's got some buttons on it. So the thing I'm going to do is I know it's sort of this controller game thing, and there's some buttons, and I'm going to press the button on the controller and see what happens. Now, this is the black box. Inside that magical game console is the rules. So it's got a physics engine, for example, in this particular case. And it says, well, he pressed the button. I'm going to run this code and execute some physics. Woohoo, isn't that awesome? Player has no idea what's going on at this point. Just magical stuff happening in the black box. Then at that point, it says, now we're going to render some feedback on the screen. In this case, it can be auditory feedback or visual feedback. And I'm going to see Mario jump. So Mario's jumped, and then the player sees that, and he updates his mental model. So really basic thing, have an idea of what's going on, do an action, black box executes a bunch of junk, who knows what, get some feedback about what actually happened, update your mental model, try again. So if you look at this is very, very simple idea, but this actually has some fun ramifications. So when you go through this loop, you tend to be learning a skill. When you're updating your mental model, that's a thing called learning. And we're changing our brain. So games change your brain at a fundamental iterative level. So we go and we process what's happened, and we update our mental model, and we say, aha, now I know how to jump. I've acquired a skill. And when you acquire that skill, when you go through this enough, learning, something interesting, anticipation, oh, I figured it out. This is how you jump. And you're like, ha, and you laugh and you smile, and you have this moment of delight. So if you've ever read anyone, Theory of Fun, Ralph Koster, he basically talks about this in here and how, like, through that learning process, through that process of mastery, you end up gaining this moment of delight. And that's one of the big emotions that we recognize in games. Now, so the big thing I want you to take away from here is learn to identify these things, these little loops in your game. What are the player's mental models? If they have the wrong mental model, then they're not going to understand what you're trying to teach them. For example, if they don't know what a console is or that you're supposed to press a button, have you ever handed a game controller to someone who doesn't know that it's a game controller? It's like they're like, what do I do with this thing? Do I move it around like this? And they're like, no, that's next generation. To identify actions. So what are the things, what are the verbs of your game? This is the first step I go through when I'm designing a game. I say, what can you actually do? What does the player do? Then the next thing is like, all right, there's these rules, and we'll get into some systems for how you build those rules. But the next step that usually happens is the player doesn't understand what the heck happened. The loop is broken because, like, I did this thing, like you were talking earlier about, there was a tutorial and they did something, and then I put the error message at the bottom of the screen and nobody saw it. And then they were confused. And so that's what happens when you're going through a mastery learning loop and you stop learning. You're like, I was doing this thing and I was learning something, but now I'm not getting the feedback I want. What the heck? Super confused. And then they may stop playing your game at that point. So anytime you see a player going through one of these loops in your game, they can fall out. The loop cannot complete, and they can either be bored, they're like, I'm not learning anything, this is dumb, and they move on. Or they can say, I didn't see the feedback, I don't understand what's happening, that black box is too mysterious. And then they leave your game because they're like, I'm confused and irritated, this is a stupid game. So by identifying this wonderful little loop throughout your game, and then figuring out where it's breaking, it's a great analytic tool for all sorts of different types of games. Theory of Fun, you should go and grab it and buy it. And there's only a handful of design books out there that are worth having. This is one of them. So skills are complicated, and some skills take a really long time for players to learn. If you went and gave Metroid to your typical user and you said, here's the end boss, beat that boss. And you said, we're not going to train you, we're not going to teach you anything, we're just going to give you a bunch of tools, we're just going to say go. Most people would fail. You know, they wouldn't do a very good job. You of course hack it, so it's really easy for them. That's one way to make them feel powerful. But for the most part, if you try to put people in a scenario where they have to use everything all at once and you haven't trained them up on these skills, then they'll generally just and keel over and die, which is really unfortunate if you're doing playtests. Dead user testers. You're like, I would have bought you coffee, but now I don't have to. So the concept of skill change is really simple. So so you've got these atomic skills, these low-level skills like jump in Mario and move, and then you can combine those together to do kill Goomba, right? And if you see in a playtest, you say, I know he's supposed to kill the Goomba, but he's not. You can ask the question, well, why isn't he? Is it because he doesn't know how to kill the Goomba? Or is it because he doesn't know how to move, which is usually pretty obvious? Or is it because he doesn't know how to jump? And you end up with this hierarchical tree of skills that you end up mapping onto your game. And this is useful in all sorts of contexts. You can use this to design your levels. You can say, hey, here's the fundamental skills that we need to teach that lead to these higher level skills that we teach in later levels, and you scaffold the player up through the various concepts. And again, these are all loops. Teach the loops, then teach the loops and how the loops feed into other loops, and it goes all the way up, you know? And if you look at some games like chess or League of Legends or some of these, you know, more multiplayer games, like the higher level skills that you have to master are amazing, and they're composed of dozens, if not hundreds, of these lower level skills. And you can actually get people through your game into those expert levels of mastery a lot easier if you understand what the heck the links are between those things. So ask questions like, what skills exist in the game? What are the subcomponents of those skills? What skills require other skills? What skills do player burn out on? Like this concept of burnout, when you're going through that loop, you can almost think of it as light bulbs. You have this entire chart of skills, and it's like, ooh, they accomplished this one, they accomplished this one, they're not getting this one. Oh, but that's because they failed down here, and it's like a light bulb that's burned out in the player's head. You know? So by identifying this, you can debug your game design. Now, there's another part of games. We always talk about like gameplay versus story, right? And we make this huge like distinction between the two. I like to think of it in terms of loops, which are these interactive mastery scenarios, and arcs, which are content delivery systems, payloads of content. So an arc is really just a broken loop. Same exact thing as a loop, except instead of you're not doing iterative passes on a skill to learn it, you're doing basically one, maybe two passes of interaction in order to deliver something that is this thing called evocative stimuli. So if you think of it in terms of a, like, who here's played Dragon's Lair? It's not a dead example yet. So Dragon's Lair is, you go in, there's an arcade, there's a joystick, I'm supposed to fiddle with the joystick. The rules are really, really simple. If you do the right, what?
Left or right?
Yeah. if you did the exact sequence, then you get to go and get feedback. Now the interesting thing about feedback in Dragon's Lair is the game is dumb, right? The game is the equivalent of turning pages in a book. But they invested a massive amount in this evocative feedback. Evocative feedback is, it's the way the brain works, right? So when we store a memory of something, we store not just like a simple memory. It's not like, oh, here's the memory, it's a unitary thing. What we do is we store like that plus a network of connections. And then along with that network of connections in your brain is also a bunch of emotions. That's sort of your fast response system. Because like, if something important is happening to me, I need to be able to respond quickly. And the conscious brain can't respond quickly enough, so we rely on sort of, more primitive is probably the wrong term, but rapid response systems for like dealing with that scenario immediately. We think of that rapid response system as emotions. Right? So you see a stimuli. If the stimuli is strong, it's going to create a huge wash of activation in this network associated with that stimuli and connected to other pieces in that network in your brain. And then you're going to pull up the emotions associated with that. And it's going to be like, whoa, this stimuli means this. I should run away, or I should be happy, or I should whatever it may be, right? So these feedback systems, these evocative stimuli tend to be like over the top. This is Dragon's Lair, right? This is over the top. You've got the big beefy man, who looks a little. Is he French? I never quite understood. But then you've got the crown, which is a symbol of she's a princess, and she's obviously she's like a woman, and it's like it's they're taking, and this is what they did. They took these stimuli and they turned them up to 11 because they want to activate that network in your brain as much as possible. Now, what's interesting about this is once you've seen it, it starts to lose its power. You're like, there's no actual loop that's completed from this. This is the sugar of interactive games. You're not learning a long-term skill. You're getting a blast of evocative stimuli that may or may not work. You may have negative associations with that. You may have positive associations with this. But once it's gone, it's gone. And that's why it's an arc, because it ends. And so what you do is you do what books do. You take a sequence of arcs and you deliver bursts of emotional stimuli one after another. And after a certain period of time, there's a reason why movies are only as long as they are. People start to get a little tired of it. And you burn out on it. It stops. So this is a building block. We use this in games all the time. It's not nearly as blatant as Dragon's Lair, but we use them constantly. And we figured out architectures for putting these things together. So we say, let's do an arc. So we get you excited and interested with an initial burst of content delivery, and then we do a loop where you're mastering something, and then we do we sandwich that with another conclusion. And if you looked at like, Deus Ex back in the day was like, we think we've solved the solution. We'll go and we'll do a cutscene, and then we'll have this sandbox that you play in, and then we'll do another cutscene. And then everyone copied that, and it's kind of become rote now. But that is an architecture for assembling arcs and loops. Now, once you understand that these are building blocks, you can do the Lego thing. You know how they tell you, like, Legos, you can put them together any way, and you can make this exact thing on the box, and that's what you do? You don't need to do that. Once you know that you have these awesome Legos, then you can say, hey, what if we go and, like we're making a roguelike, Road Not Taken, and we're saying, look, we actually have lots of loops in that game. There's lots of skills that you can learn and how they're nested and how they connect together. And we're going and we're identifying the individual skills and the individual moments in the game, and we're adding like lots and lots of little micro arcs inside the loop. And we're randomizing them and generating them in particular ways. So like, who knows what you're going to get? There's an element of surprise. You'll still only see them once because we know that you burn out. But they end up being these little moments of evocative delight inside a very gameplay-centric thing. So think of architectures. Identify what are the arcs in your game design, what are the loops, and then play with the architecture a little bit. How can you combine those together in interesting ways? Now, loops and arcs are awesome. Totally amazing stuff. As soon as you start seeing them, you'll start seeing them everywhere. And it will be kind of like Legos. Legos can be overwhelming. It's like, what can I make with this? I can make anything with this. How do I analyze this game design? Well, I've got these 20 different questions I could ask, and I could change this portion or this loop or this arc, or I could make this stronger or change this feedback, and it just becomes overwhelming. So how do you prioritize what you should focus on in your game? And there's this thing called frequency. So I don't know if anyone can see that down there. It's a little hidden. It says at the bottom, it says fast frequent loops. And at the top, it says slow infrequent loops. And when you're looking at a game, usually there's things that you're doing all the time, over and over and over again, and they tend to be these basic skills that you use again and again as the components of these higher level loops. And then there's things that you do occasionally, like let's say jumping in Super Mario. That's something that's a high frequency loop, right? You're jumping all the time. And then there's things like ending the level. I don't think they spent a lot of time on ending the level personally. It's not that exciting. But it happens occasionally, every few minutes, right? You end the level. And then there's actually like finishing the game, which is really more of an arc than a loop. And finishing the game, I don't think they spent any time at all on that, right? They had some guy that's like, hey, yeah, we need, make sure it's not an error code there. So by looking at these, you ask, why do games not have good endings? Because a good ending is the least important thing in the game. Because the process is going through these fast, high frequency, tiny loops and mastering things and using those for the intermediate levels and so on and so forth. The actual end of the game means the game's over and you're not getting those little moments of delight any longer. So 95% plus, depends on the game, is going to be spent in that core loop. Maybe you should spend your time there. There's a reason why the early Nintendo games, a lot of them were created as little sandbox levels. They would have a little sandbox where all Mario does is jump around, right? Because if that foundation wasn't good, the rest of the game wouldn't work. So this ties into the skill trees we talked about earlier. How these little things are building blocks for the bigger things. So whenever you're having a problem, ask the question: what's the highest frequency loop in your game? Are you giving it the love it deserves? is it delightful? Is it a strong foundation for the rest of your game? Because if it's not, you might as well just throw away the whole thing. Because if that core loop isn't there, then you've got nothing to build on. It's like building on sand. As you get into these super high frequency loops, you need tools to understand why they work. And how they work, and break up and analyze that experience. This is attack, sustain, decay curves. And this is from Steve Swink's game feel book, if anyone's read that. It's awesome. That's the other book you should get. If you haven't got that one, go for it. It's, if you do any sort of real-time controls in games, you probably should get that book. So the basics are really simple. Hey, I've got some velocity on the axis here, and I've got time going along the horizontal axis. I press the button down. There's some sort of attack. I'm going to change my velocity. Notice these are just simple linear equations. There's nothing crazy about this. It's just a line. Really easy math. You've got a sustain. Say this is a max velocity. And then you've got a decay. I release the button, and my character comes to a stop. Now, with this very simple model, you can do most control systems on the planet. So it starts to get a little wacky when you're talking about pattern recognition on, Connect and things like that. But for the most part, this is a simple model that scales really well to a whole bunch of different scenarios. Like, we were dealing with one game. It's a kind of an odd platformer type game that we're making. And we found that it was really fun to get up to speed at first, and then it kind of became boring because there was this long period of time where you just were at max velocity and it wasn't enjoyable any longer. And so we said, well, there's kind of two pieces to that experience. There's the, I want to get up to speed really quickly, and then I want to feel like I'm building up momentum and velocity throughout. So we kind of said, here's the experience I want, and I'm going to describe that experience. And I'm going to split it up into two. I'm going to identify verbally what those two sections of the experience are. And then I'm going to draw the picture, draw the math that represents that experience. And this is where the fact that you're dealing with incredibly simple lines actually helps, because instead of having to say, well, what's the curve that does this particular thing, you don't have to worry about that. You just say, oh yeah, there's this initial experience where I get up to speed really quickly, and then I go and I build my velocity slowly over a period of time. All right, done. Right? And this is sort of, I like to think of this as what is the moments in your game, the moment by moment. Here's what it feels like when he's jumping off the mall. And then take that and break that down into, here's the variables involved, and here's the timing on that particular moment that I want, and here's the rates that things change at, and then draw the picture. And then you can almost always turn that into code, and it's really straightforward. So yeah, that's pretty much what I said right there. These discrete moments, it's a hugely important skill to look at a game. We tend to look at games as players as this holistic, it's like we're bathers in the ocean, It's like, oh, the waves of the game are coming over me, and it's so nice, and oh my God, is that a shark? Oh, and it's just this holistic kind of experience, right? But as a game designer, what you're doing is you're saying, no, there's a point at which the person is in the trough of the wave, and this is how we're going to model it. And then there's a point where the wave hits them, and this is the strength of the wave that we want to model. And be able to take that experience and split it up into individual moments, and then tune those and critique those and say, look, it feels slow here. Well, I know exactly what that moment is. I'm just going to change the timing on that. It feels better now. And that turns that holistic, fuzzy, game feel stuff into something that's very concrete. Game feel. That's the book. I'm just going to go through this one quickly because it's awesome, and I want to leave you waiting, wanting. So this is Joris Dormans. is a fellow over in Europe, and he came out with this. This is some of the game grammar stuff that's been percolating for ages, and this is the first useful description of it. Has anyone here played a German board game? This stuff describes every single German board game on the planet. It's crazy. It's like you look at this stuff and you're like, oh my God, it's Settlers of Catan. You know, it's wild. So it's a really simple sort of concept. You know, you see this in MMO economies as well. You've got sources. There are things in the game that build resources. Yes. There's pools. I can hold a bunch of resources of a particular type. For example, maybe there's something that makes sheep. We all like sheep. And then finally, there's a sink. There's something that gets rid of the sheep. The authorities come and take away your sheep. It happens. I have no personal experience, but just... so sources. It's always good to have a strong visual metaphor. Think of these sheep. You own lots of sheep. Or authorities come and take the sheep. All right. Good. Now, we can do things with those sheep, right? I'm just going to run with this metaphor. This was not planned, but it's in my head right now. So we have a pool. We have a pool of resources, and there's an action that you can do. Maybe it costs some of those resources, but in turn, it increases the rate at which those sheep are being produced. Maybe I sell the sheep to the butcher, and then he goes and does something that makes more sheep. I don't know. The metaphor starts to break down right there. But German board games do this all the time, right? You have a power-up. If you spend on in this particular building, then the building will suddenly go and allow you to make more units at a faster rate. And you start to see these internal economies start going together. Now, this is an example of something, this is a positive feedback loop. So I don't know, if you've studied game design, you've usually heard, oh, positive feedback loops, they accelerate things, and then there's negative feedback loops, and they decelerate things or dampen things down, and it's kind of this vague, fuzzy concept in your head. What's nice about this system is now you've got a way of talking about it in very concrete terms. It's like, oh, I just changed that modifier, so I get half as many sheep now being produced from this source, just by changing that one number. So it's the same network, one number difference. Now I've got a negative feedback loop instead of a positive feedback loop. And there's a bunch of other like little atomic units that you can do to describe how resources flow. You can convert resources into other things. You can say, I spend these 3 resources and get this one resource out. You can do really interesting things like you say, oh, time is a resource. So I can be abstract. I don't have to talk about concrete sheep. I can talk about time instead. So a player has a certain amount of time that they can spend. What are they going to spend it on? As soon as you start getting like here, this is one action you can do. As soon as you start having multiple actions you can do, now there's choices. You can hook up graphs to this stuff. Like I can hook up a little meter, some metrics to here, and I can see like over 100 plays, how does the pool of resources change over time? And you can actually look at the graphs based off this very simple model. Trade, you can do trading systems with this. You know, you have different players. You know, player 1 produces good A, he collects good A, he has an excess. If he trades, then he goes and he gives it to group to B, and now B has, you know, A and B, and maybe there's a recipe that makes that more valuable. There's all sorts of, like, any sort of internal economy stuff you can do that. Now, this is what it looks like in practice. But the theory is one of the things that helps you understand this madness. All right, so what are the resources? What are the feedback loops? What are the transformations of those feedbacks? What is the architecture of, again, architecture, that word comes up a lot, of how resources are used and consumed in your game? It's really funny, like so many prototypes, if you don't do this thinking, you just have this like one resource that just starts accumulating someplace. And you're like, wow, that Diablo auction house is a bad idea. But you can fix that by understanding, hey, maybe we need stronger sinks here, and you can start to analyze some of that. This is the book. This is another book you should get. Out of the dozens of game design books, I've only given you 3. Culling. Tuning for flow. You've heard of flow. Theory of flow. And everybody say the name of the guy.
Csikszentmihalyi.
Csikszentmihalyi, yes. So Mikhail Csikszentmihalyi, which doesn't look like how it's pronounced at all, came up with this concept of optimal experiences. Like, hey, we go through life, and there are experiences that are too frustrating. It's kind of like the Goldilocks and the little bears here. It's too hot. It's too frustrating. It's too cold. It's too boring. And then in the middle, it's just right. So you see this with game designs a lot. Even after you've got your loops and everything all set up, even after you've got all your people are making these wonderful decisions about the economy and the controls feel right and so on and so forth, you still have to tune for all these. I think of it as cognitive load is how I tend to think of it. As like, is the time pressure in this optimal flow channel? Is the execution pressure in this optimal flow channel? Narrative momentum, is it too fast? Is it too slow? And so you can end up like looking, again, break it up into pieces, understand what each piece is doing. Are you in the flow channel? Adjust. All your standard questions. Noise is a really interesting one. That's one we tend to ignore. So you're playing a game, and there's lots of things you can do, and there's only a few things that are meaningful, but someone has gone and made the graphics super realistic, and you can't tell where the ledge is to jump on, right? Because what they've done is they've added too much stuff to the game, and it's become noisy. And because it's noisy, people become frustrated when they didn't need to become frustrated. The game mechanics are actually dead solid. I'll pimp my Lost Garden. That's my website. That's where these slides will be. There's a essay up there that talks about how you tune your game and what are ways of making it tighter or looser in terms of flow. That's it. That's all I got. You've just gained like at least 10 years over me. I expect great things. Is that how we're doing on time? Is there?
Oh, you got plenty of time. Lots of time for Q&A, I think. 20 minutes.
Oh, nice.
You're right. Just well done.
All right.
Going back to the ASD curves, once you draw your picture, what it looks like, how do you tell a fun one from one that isn't fun?
You play the damn thing.
So if I have a picture at all, but
Because, again, a lot of these things are inspection tools. So you've played a prototype. You've said, it doesn't feel right. There's something wrong about it, right? And then you're like, what's the section? And then you break it up and say, this section is off. And then you're like, okay, this section's off. I need to change the time, change the time. Often what ends up happening is you don't need to change the timing because you don't have the model yet. You say, I need to model why this is broken. Then you draw your curves. This is the model that I think it will work. Then you implement that, and then you see if it works. Yeah, it's more of a way of coming up with an editable mental model for the system as opposed to an uneditable, like, I've got all these crazy forces and I have no intuitive sense of what they actually do.
so is that something more useful for a designer communicating with a programmer? Less useful for a guy like me who's going to
It could be. It could be. One of the things I've noticed is if you do this long enough, you've built up your own deep wellspring of experience to draw upon. And you have an intuitive sense of what works and what doesn't. However, I have that as well, right? A critique that I give myself quite often is you may know something feels right or doesn't feel right, and you may have patterns that you rely on, but you're unable, because it's purely instinctual, intuitive knowledge, you're unable to take a step back and say, what are the actual pieces, and what if I did this instead? Because you don't have symbols to manipulate. You have gut, which is not a manipulatable symbol. Yeah.
Have you played Game Dev Tycoon yet?
I have not.
I highly recommend it. It seems to me that you're essentially expressing an equivalent of the slidey bars that let you kind of tweak your game. So this seems to me like a methodology of visually displaying, and allowing you to tweak different elements down to however granular you want to get. Is that correct? And like storing the information like an INI file or a database of some variety?
Yeah, you can get this all the way to implementation. For the most part, these are theoretical tools, so you're using them like mostly I just use them on paper, right? They don't have to go all the way into the tech.
So it's not like Tableau for video games.
No. And again, that goes back to this. This is not the magical equation that you plug numbers in and you get a game out. These are all like thinking tools. Yeah, just like math is a thinking tool for the most part. Any other questions? Yes.
With all the various failures that you've had, and as a designer, kind of just that's part of the process. It seems like the better the design, the more comfortable you are with failure. Have you noticed how you treat discovering and finally determining that something is kind of a failure, time to move on? Have you noticed how that has evolved from your own viewpoint?
Oh my God. I am so horrible about telling when something's a failure. It's brutal. So this is the lie I tell myself. The lie I tell myself is that by understanding these tools, when I actually have to kill a prototype, it will somehow make that easier. But that's not what happens. Like killing prototypes and coming to the brutal realization that the prototype is bad is still an immensely emotional moment. Like I'll lose weekends where I'm like, I'm so depressed. I have to kill the prototype tomorrow, and I don't want to do it. Yeah. So, and because there's this emotional element to it, and because we are emotional creatures, I find myself like going and saying, I've got all these tools, I can use these tools to fix it. I can make it better. And sometimes that works and sometimes it doesn't.
Have you ever had to kill something twice? have you just
the undead.
With a bad idea that you just like, a year later you come back. I can revive it. I know how to do it.
What usually happens is in the middle of the project, I say we can reboot it. And it's like we take this design and it's not working out, it's not fun, but we're just going to keep the same concept. And I fall in love with concepts, which is something you should never do. Greenlighting a concept, I think, is the worst thing you can possibly do to a game. Because you fall in love with a concept, and then it's not working at a mechanical level, and then you say, well, we'll keep the same concept, but we'll change the mechanics and make it better. And then that sucks, and then you do it again. And so it's kind of like, we're going to keep the same head, but we're going to chop it off of the neck and weld on a new body. And it doesn't, I've done that many times. Yeah. Yes?
When you're modeling stuff like movement with the attack, sustain, decay, that's a single system. That's, you're jumping, for example, like the Goomba.
Yep.
The Goomba has their own system of motion. I feel like out person can get lost in the weeds, so I was trying to compare two graphs, two different models with different systems involved. Do you find that this still helps the system you have, or is there a different way of tackling that sort of interaction?
It's actually, it actually helps a lot, because what it does is it allows you to say, like, all right, the Goomba's moving in a particular way, and then the player's moving in a particular way, and we'll treat those as separate for now, and then we can say, okay, and then there's this moment of interaction, and You actually do this with platformers all the time. Like the physics for like when you're hitting a wall is often completely and utterly different than the physics when you're in the air, which is completely and utterly different than the physics when you're on the ground, right? So often what you'll have is you'll say, all right, I'm now interacting with this object, and now I'm going to define that experience right there. And you can kind of piecemeal define that. And it may be a very short thing. Like especially when you're dealing with real-time stuff, there's this wonderful perceptual window where you do something and you meant to do it, but you're not conscious that you meant to do it, that you decided to do it. And it's about 200 milliseconds. So you'll find you're moving along and you do something, and you have basically about 200 milliseconds for your conscious brain to catch up with the fact that you decided to do that. So you get into these really weird situations. I don't know if anyone does mouse overs on different things. You'll find this window of about 200 milliseconds where if you don't have that delay in there, someone will mouse over a button, and they'll just be doing it. They don't intend to stop there. So they'll just mouse over it, and if you don't have the delay, the thing will flicker up, and it will be really annoying because it flickers up, and then they move off the button and then goes away. And you're like, oh, that was so annoying. That stupid mouse over keeps coming up. But then if you put a slight delay on it, so let's say you put a 1 second delay on it. So they have to hover over the object for 1 second before you pop this thing up. They're like, they hover over it, and then their brain says, wait, I intentionally, my brain catches up, I intentionally meant to hover over this, and now I'm waiting, and it feels so long and painful. And then the thing pops up, and you're like, this is the dumbest system ever. Everything's so slow and clunky. So the trick is to make the delay like a little less than 200 milliseconds. And what ends up happening is you move over the button, you stop, you don't realize you've moved over the button. You're hanging out there for multiple milliseconds, and then the thing pops up, which feels really crisp and good, and then your brain catches up, like, of course I meant to be here, and everything works perfectly. So often when you're dealing with these like real-time interactions, you're manipulating segments of experience that are within like hundreds of a millisecond, tenths of a millisecond thing. So it's actually, I find it very useful for those moments. Yeah. Yes.
I have two questions. I missed the second book that you recommended.
Was it Game Feel or? Yeah.
And
Steve Swink.
Do you modify things depending on the demographics of your target player audience, or like shorter loops, less arcs, depending on who you are?
I don't. Not really. There are distinctly different play styles. It tends to be, I don't tend to think of it in terms of demographics. I tend to think of it more in terms of play style. There's certain people who like more relaxing games. There's certain people who like, more intense, over-the-top games. Like you look at something like BioShock, and I find it difficult to play BioShock because it's essentially these really intense, tuned to 11, evocative stimuli, right? You walk down the hall and this horrible thing happens, and then you walk a few more feet and another horrible thing happens. And that's not what I'm into as a gamer. That's not my thing, I want, I make Triple Town, I make little peaceful bears, that you turn in, that you do genocide on, to your colonialist inclinations. But it's a different thing. So there's definitely different play styles and different preferences. I mean, we're ultimately building an aesthetic art here, right? So not everything you're going to do is going to appeal to everyone, and you kind of have to have an understanding of what you're going for. Yeah. Yes.
Have you had a challenge of a game design that came out a little too zen, and you felt you had to add intensity to it? And if so, how would you break down the approach to fixing that?
A little too zen. What would be an example of that?
Flow is a little too zen sometimes.
Yeah. I'm trying to think of one of my designs that's been that way. I mean, it happens with. Example would be something like the basic version of Steambirds was. It's a pretty, like, we built it to be a certain, Steambirds is a turn-based strategy game, but the idea, we took some of the aesthetics from overhead shooters. So you have a plane, you have a directional arrow, you can move that, and then you press space and you go in that direction. So it's turn-based, but it's very, very fast-paced for a turn-based game. And in the survival mode, originally there were just waves, and it was like you could go forever just killing things, wave after wave after wave. And we're like, okay, well, we want to increase the type of pressure on the player. Now, pressure is an interesting term because there's lots of different types of pressure. You know, you can have time pressure, where you're like, okay, I can add, like, you have to finish your turn faster, and if you don't, then there's some penalty, like you made a bad move. Or you can add, like, complexity pressure. Like, I could add lots more planes coming in, where it's like, I can't deal with all the planes coming towards me. I could add, like a certain in that game I can add a tactical pressure to it. Like I can say, all right, there is a correct way of taking down this dirigible. I have to get right behind it, and I have to like shoot it from behind. And there's like a 5-degree arc there where I can fire at this thing. And if I make one bad mistake, I'm dead. So you can make these brutal, difficult penalties, you know. And so these are all ways of like tuning that pressure. And those type of things come up in every single game. Yeah. Oh, yes.
How would you define success for a game designer?
There is no success for a game designer. So for me, I like seeing players play the games, and I like seeing them play them for years. There's a few games, actually most of the games that I mentioned that I've worked on, people are still playing, which to me is a form of success. But the ones that have a rich community years after their release, that's a success for me. Like Tyrian, which was, it's a vertically scrolling shoot 'em up, which was the first game I worked on. At a certain point, we released it open source, and it's now on like every platform underneath the sun. It's another way of making a retro game. Make a retro game, open source it, and then let it live forever. That's still being played, and people still seem to enjoy it, and there's communities that still actively talk about it. So that's a form of success.
You strike me as someone who likes Dwarf Fortress.
I don't. I don't actually play Dwarf Fortress. I don't have the time.
Losing is fun. There is no win condition.
Right. Yeah. Yes.
You talked about concepts that don't have the post-private playtesting to carry them, and you talked about play mechanics that don't always turn out the way you want to. Do you have like a morgue of play mechanics that you're like, this didn't work for this concept, but I'm going to reuse this, I'm going to revisit this, or do you throw it away and rebuild from scratch?
For the most part, I throw them away. So I do a style of design which isn't for everyone, but I think of it as designing from the root. So I tend to focus, I go all the way down to what is the base, high frequency, interesting mathematical puzzle. There's another, math topologies. I didn't get it to this one, but there's another. This is difficult to master math topologies. So you know, NP complete, NP hard problems. You know, traveling salesman type stuff. And I didn't include it because this. You just need to go here and look at this presentation. This is one of Raf's, and he goes through like. Vertex matching and tile matching and all these different types of fundamental mathematical problems that end up being at the base of a lot of what we do as game designers. So I try to go and find these little nuggets of almost mathematical fun. And then I build the game up from there. So what often happens is my prototypes are things that the little nugget isn't fun, so it's not as easy to reuse that. Yeah. Yes.
You said it's a bad idea to be married to a concept and try to squeeze a bunch of the work concept, squeeze a bunch of mechanics in to make it work?
I find that to be bad. Some people have more
Do
success.
you think the opposite might be a little better in where you think there's a mechanic that might not work for the concept, but you really want that mechanic to work somehow, and you want to rework that? I mean, is that more...
I tend to work on the mechanics, and then find a theme that seems to fit the themes. I think of themes as stories, right? Themes are like these lessons that have been passed down that are worth remembering, that have a certain like arc to them and an emotional quality, and they like they're an entrance into, because we know them and because we know the story, they're an entrance into the game. So what I found is there's so many of these stories out there. There's a vast number of them that you can usually go and say, here's the game, here are the emotional moments in the game, and then here is a existing narrative that maps onto that pretty reasonably. We did that with Tripletown. I don't know if it was 100% successful, but there's this idea of building. Okay, let's pick a theme that involves building. You know, there's these peaceful creatures that you go and massacre. Let's pick a theme about these peaceful creatures that you massacre, that you feel a little guilty about, but then you also are just frustrated with them and they deserve to die. You know. And it's a little awkward, and I like that little awkwardness. Yeah. Yes.
Is your next game going to involve sheep?
There are no sheep in the next game. However, this is very important. There is a goat.